In the last topic, we have seen the basics of the vibration system. In continuation in this topic, we are going to be learn the parts of vibrating system. See, in this case, the parts of vibrating system. So this was developed, as we know that from that, the basics of the vibrations, we understood that the basic cause for the vibrations of the system is going to be the mass, spring, or the main basic or the inherent properties of the system, right? In this case, what is the vibrating system? That what are the parts are going to be helping for these vibrations we are going to be discussing here. So as we have seen the part, so that's the totally I have converted into the pictorial way. The first one is going to be the spring, the second one is the damper, and third one is going to be the mass, right? And these are going to be the spring and the mass are going to be sometimes the inherent properties of the system, right? And this is going to be the damper, which is going to be resist the motion of the vibrating system. So from this one, and this is going to be the excitation. So then what happens? These excitations will generate the energy within that system, right? And so that it displays from its mean position and starts to vibrate. So that's points we are going to be discussing here. As we know that the vibrating system, they basically consists of the three elements, namely mass, spring, and the damper. Just we have discussed mass and the springs are going to be the inherent properties of the system, and the damper may be inherent properties sometimes, or sometimes we are applying mostly from the external excitation. So that's going to be three elements. In the vibrating body, there is exchange of energy from one form to the another form, right? So from one form to the other form. So it is very clear that the assumption is very clear. Vibrating system is an energy conserving unit which converts from one form to the another form of the energy. So as we know that what kind of energy forms we do have in the vibrating system, that we are going to see, and each element, what are the energy it possesses, that's we are going to see here now. The energy stored in a mass in the form of kinetic energy, right? This mass is going to be consist of the kinetic energy, right? That mass is possessed because that mass is in the motion. That motion will create the kinetic energy to that system. And the second one is going to be the spring. The spring, the energy stored in the form of potential energy or elastic energy, that's going to be of kx squared. As we know that this is going to be the spring system, its energy stored in the form of the potential energy or the elastic energy, that is due to the elastic deformation of this spring, right? And that's going to be next, the energy dissipated in the damper in the form of heat energy, which opposes the motion of the system. So in this case, the energy is going to be disapiating in the form of the heat energy. As we know that the damper always, it will create a resistance motion to the motion of your body, which is trying to oppose and it's trying to bring back to the equilibrium position. So in this way, we are going to be, the mass is consist of the kinetic energy because due to the motion of the mass, and spring, that's going to be due to the elongation in the downward direction. That means elastic deformation is going to be consist. Then we can say that's going to be consist of potential energy or elastic energy or the strain energy. And this damper, it is going to be, the heat energy is going to be generating to remove the excessive energy within that system. So in our definition we have seen the system is going to be energy conserving unit. Then how this energy is developing within that system? What is the main cause for that kind of energy generating? So the main cause here, that's due to the external excitation. So in this case what will happen? So this is going to be the external force is going to be the main. So this external force is known as the excitation. So what is that? Energy enters the system with the application of external force and known as excitation, right? In this case what will happen? I am going to be giving an initial displacement to this system. Then what happens? Initial displacement. That means I am applying the external force to that system, then this system is going to be start to vibrating in the downward direction. So that means from that mean position it's moving into the another position. So right, in this way the energy, when it is moving in the downward direction, so this mass is consist of motion. So then when it is in the motion, that means accelerating force is going to be generating, that's going to be stored in the kinetic energy. And similarly, the spring is going to be start elongating. That means the potential energy is going to be generating. That's because of the elastic deformation. In this case, what will happen? It's trying to move in the downward direction. This damper is going to be going to be elongating itself, but it's going to be time the heat energy is going to be generating within that system as per the previous definition. So that's what he's saying, the excitation disturbs the mass from its main position, right? When I am applying the force, that means external excitation. Excitation is nothing but the external force. Then what happens? The system is going to be reached to the new position. So then the mass goes up and down from its main position. Once you remove this load, on this one, then automatically the system is going to be trying to bring back its original position. But due to the excitation, it's moving in the upward direction. As we know that this is the way the energy conservation is going to be taking place from kinetic energy to the potential energy. That's what he's saying. The kinetic energy converted into potential energy and the potential energy converted into the kinetic energy. This is what we have discussed in the basics of the mechanical vibrations. The same principle we are applying here. So then what happened? It's when it is in the motion, the kinetic energy is gaining. Then what will happen? It is converted into the potential energy. Once it is going to be moving back. That's the potential energy converted into the kinetic energy. The sequence goes on repeating, right? Because until it possesses that energy within that system, it will goes on repeating that means it will repeat the same kind of process. The system continues to vibrate until it's going to be die out internal energy. Thus we have seen how the system is gaining the energy from this external excitation. So then when it is going to be comes to its equilibrium static position, right? We disturbed it from the mean position, so then it's reached to the new position. So then what happened from when it's going to be come back means when it is going to be the internal energy of the system is going to be die out, then automatically the system come back its equilibrium position. That's what we are going to say. That's why this damper is going to be helpful in this situation. So then what will happen? At the same time, there is a damping force acts on the mass and which opposes its mass. As for our point of view, in the vibrating point of view, this damper mainly designed to oppose the motion of the unnecessary vibrations. Suppose you are traveling on a bike. So then what will happen when you are moving in the rough roads? So in that case what will happen? Those vibrations should not come to your body. So then what happens? These dampers and the spring system, they are going to be combinedly, they are keeping and they are going to be arresting these vibrations so that your body will feel a little comfort. I hope you understand what is the main purpose of the damper. The damper main purpose itself is going to be absorb that energy and that energy is going to be dissipated in terms of the heat energy because inside there is a fluid is there. That fluid is going to be moving in the small orifice. So that's what I am saying. At the same time, the damping force, right, acts on the mass and opposes its motion. So then some energy is dissipated in each cycle of vibrations due to damping. Right, and then what will happen? This system is going to be vibrating like this. So then it will go into the downward direction and upward direction, but it can't stop at the main position because already it possesses some energy, right? So at the main position, what will happen? It have the maximum kinetic energy. At the extreme positions, would have the maximum potential energy. That's the way energy is going to be conservation is taking. So then what happened? The heat energy is going to be dissipated from this system. So then the free vibrations die out and the system remains at its static equilibrium position. Then what will happen? How these free vibrations are going to be die out? Because when you have a spring and mass, it will take a lot of time to come back its equilibrium position. But once you added the damper into that system, then what happened? It will absorb that whatever the vibrations are coming, that's converting into the heat energy. So once heat energy is going to be dissipated. So then that's finally that exciting energy is going to be dissipated. So when it comes to the static equilibrium position, then we can say, then we can apply the equilibrium method for the analysis of the system. Then that's going to be the algebraic forces acting on the system is equal to algebraic, that means algebraic dynamic forces and the net moment forces acting on the system is equal to 0. So then equation of motion that we have derived, that's going to be mass into acceleration plus damping coefficient into velocity plus spring stiffness into displacement, that is equal to 0. Then what is this one? This is going to be the inertia force, and this parameter c into velocity is going to be your damping force. Kx is going to be, that is going to be our the spring force. This way the vibrating system is going to be working out.